everyone, thanks for joining today's discussion. We are assigned to develop a system for weather prediction, so we are here to discuss which deep learning method is the best to predict weather event. Before we start our discussion, let's introduce ourselves. My name is Darshanaa, daughter of A Kumaran, and I am the data expert and also your group leader. So guys, you can feel free to share your opinion.
Hi, Ms. Darshanaa. My name is Danish bin Mohamad. I'm as a machine learning engineer. So my job is to turn weather data into relevant predictions.
Hi all, I'm Omar Hamiduddin Moidin, the system developer. My job is to make sure that the system have a user-friendly interface and make sure the system work perfectly with weather prediction.
Hi everyone, I'm A M Abujarad, the disaster response coordinator. My role is to plan how we can respond quickly to extreme weather events. I focus on using early prediction to help protect people and reduce the environmental or the impact of the disaster to our environment and people.
Hi everyone, I'm Othman, the meteorologist, also known as the the weather scientist. My role is to study how analytics and weather interact and study how these numbers can arrange the weather interactions in the air.
Alright, thank you everyone for the beautiful introduction. So let's start our discussion. Our goal today is to decide which deep learning method is the best to predict weather event. Since today we have our own role, so we can give our point based on that. So I will begin first. As a data expert, I think LSTM, which is long short term memory, is the best because weather data can change time to time. At the same time, I feel CNN, which is convolutional neural network, also can be the best also because when we analyze the satellite images. So both models has their own benefit. As we can see over here on the top, the weather data that shows temperature, humidity, wind, speed and rainfall changing hour by hour. This type of data is perfect for LSTM because it learns pattern over time and understand how weather change day by day. And below, we can list the example of weather images such as hail, rainbow, snow, lightning and dew. CNN is good for analyzing images like this because it can detect cloud shape, color and pattern that indicate certain weather prediction. So now let's hear more about this to our machine learning engineer, Mr. Danish. So Mr. Danish, what do you think about this?
Alright, thanks Ms. Darshanaa. From what I see in the time series viewer, data can be very noisy, large and also incomplete. So it could lead to some missing errors or sensor errors. So I'm as a machine learning engineer, I'm highlighting about pre-processing, normalization and handling the missing errors. And also I focus on how the model works, which is LSTM and CNN. LSTM for time-based data like temperature, humidity and wind. LSTM is a strong choice, like you said. It learns patterns over time. And it also helps us understand how the weather changes from hour to hour. But it can be very heavy. For satellite and radar images, CNN works well because it can detect shapes like cloud or storm movements. In some cases, we can even combine the CNN and LSTM because it's the best combination to get a better results. But from my point of view, it depends on what data we are working on.
Okay, thanks, Danish. From the meteorologist point of view, LSTM I think fits better. Since in weather science, we look at how weather changes over time. So how humidity can change into rainstorms, and how can that affect our data? So if we're working with something like a CNN model, we can't really use this time-based data. So I think LSTM fits better here. LSTM is really good at learning these patterns and remembering how weather changes from 1 hour to the next.
Sorry to interrupt, Othman. I just want to ask something quickly. Since you are dealing with weather daily, what do you think compared to the normal method?
Okay, it's no problem, Hamid. This LSTM can notice earlier, it picks up small changes like sudden drops in air pressure or rising in wind speed, which usually happens before a storm forms. So in this type of data, we call that time-based data. So with LSTM, we can detect danger earlier and prepare faster. I'd also like to mention though that in CNN, it is although useful for images, but most of our prediction work that's going on here is time-based. So based on my role, I find it that recommending LSTM is the way to go here.
Sorry to jump in, but I really agree with what Othman just said. As someone in a disaster response, early prediction is everything. When trouble hits or a thunderstorm hits or anything happens, the person in charge has to react fast. So we need to know what's coming early as soon as possible so we can wake up emergency teams, give a clear directions and avoid confusion to the people. In real situation, things get really messy and loud. But when we have an accurate early warning, we can turn chaos into something organized. Rescue teams, medics and support all move together like one part of a machine. That's why LSTM helps us to spot the changes in the weather before they turn to dangerous chaos to the environment.
Okay, what I can say is accuracy alone isn't enough. Weather prediction often use RMSE, which is root mean square error, for continuous values like temperature. So what I can say, we need to measure how well the model predicts by dangerous events like not just average weather.
Alright, thanks Danish. That's a really important point. I just want to add something as a data expert and the team leader. Listening to all of you, I notice we keep coming back to the same idea weather change time by time, and we need a model that can predict it earlier. So I'm starting to feel even more confident. LSTM is the best choice for our system. But before we decide, I would like to listen with our system developer, Mr. Hamid. So, Mr. Hamid, what do you think about this?
Thanks, Darshanaa. From the system development side, my main focus is making sure the deep learning model we choose can run smoothly with our system. It needs to be fast, efficient, and able to handle the real-time processing so that the weather prediction can run smoothly with our system. Now then, we look at the LSTM. It is very strong on time series data. It understands the pattern changes over time by predicting future data with detecting the past data, which is exactly what we need for weather prediction. But that's one thing we should consider. That is the dataset of this LSTM model. Because when the dataset is very large, LSTM model tend to be very slow, and sometimes give result very late. So this can disrupt our system because of weather can change rapidly. If we miss something or slower, it can make our prediction very far behind. On the other hand, CNN model are usually lighter and very efficient, and it can use on the lower hardware. But the thing with CNN is it use feature extraction. Basically, it's more on images. So when we are using for weather prediction, CNN is tend to be add-on that we can use, but it cannot be the main model. So what I think is LSTM is better choice than CNN because of the better reliability and efficiency we can take from the model.
Alright, Mr. Hamid, since you mentioned that LSTM can be very large for our data sets, do you have any plan to optimize our system properly? Because what you all mentioned, LSTM can be very heavy. So for the optimization, I would suggest using GRU for lighter algorithm. GRU stands for gated current unit, because we could reduce input dimensions and also deploy models with pruning for faster inference.
Yes, Danish. As you said, by simple term, the GRU is using by reducing unnecessary complexity or improving the dataset. So this can make the model, even the dataset is not larger, but it is efficient and can it still give accuracy not far behind from the larger dataset. We can also it also can increase our accuracy sometimes. So I think this is a better solution for our.
Alright, so based on everything we discussed today, our group agrees that LSTM is the best choice to predict weather event. This is because most of weather data change over time and LSTM can learn this pattern well. It also gives early warning and help with disaster planning and system performance. So LSTM will be our final choice for our system. So
I'd
thank
like to also add, though, for CNN models, the installation itself might take longer than it's beneficial to use. So I think, although LSTM is the choice, CNN models are too unaffordable in any case scenario. So going with that, I believe LSTM is the only plausible choice to use here.
So we decide LSTM. Thank you, team, for today's discussion.
Alright.